Good morning, everyone. Welcome back to the shop. Today we're going to start one of a series of sheet metal projects that I'm going to share with you. There aren't a lot of projects out on YouTube for sheet metal beyond how to build your own sheet metal bender. We're not going to do that. This project is going to be just a small hang-on-the-wall rack for my air chucks, or you can use anything that has a quick disconnect fitting on it. This is the standard quick disconnect most people are running. If I can find what number that is, I'll share it with you. It's not critical for the design except in this dimension right here. I'll fabricate this in a second video. This video I want to concentrate on drawing it in Fusion 360. I want to share with you some of the things I've learned around workflow and the sheet metal capabilities that are now baked into Fusion 360, as well as probably another tip or two as we go along, things I've found in the past that are helpful. Take a look at the drawing. In the drawing I've made from this original, it's basically 6 inches by 3 inches. All of these funny numbers start coming around because when you dimension in the drawing tools, it takes into account the additional material that's been put in for your bend. So now that you know what the goal is, let's get started drawing a new one. We'll start a new design. And the first thing we're going to do is save it. We're going to start by creating a sketch. And what we're going to sketch is a center point rectangle. And we're going to make it some dimensions. So one of the first things that I'm going to share with you is the workflow that is becoming ingrained in my system. And that is to start much like I do a woodworking project and just start big. In woodworking, a lot of times your first cut's a rough cut and you refine from there. So we're just going to draw a rectangle of some size. And then I'm going to give you the next tip. When you're sitting down and you're drawing something like this, you sit down, you don't probably already have all the dimensions. You're sort of designing on the fly. And these numbers are variable. And that's the key. If there are variable numbers to you, then they need to be variables in the system. So let's create parameters for some real simple things. We're going to say width. And I'm guessing it's going to be 6 inches. We're going to create the height, and this will be the height of the leg on the back. And we're going to go with 2 inches. And again, I'm, fairly good guess, not 100%. And the last thing we're going to do is width, and this is going to be the width of the part that comes out from the wall. That's how I'm going to consider this. And we'll call it 1 3/4 inches. Oh, it won't let me call it width, so I'll call it shelf. Although it's not really a shelf, there it is. So now we have 3 dimensions. So we're going to put those in here because they are most likely going to change. And we're going to assume that this is the top. We're looking down on where the holes are. There it is. Alright, so real simple rectangle. In sheet metal, you don't extrude. In the sheet metal tools, we're just going to stop the sketch here, and the first thing you do is create a flange. And the flange we're creating is this surface right here. And really what we're doing is we're giving it some thickness. There's a series of rules here, and we're going to use steel inches. And I'm not going to get into these, and honestly I don't quite understand them all just yet. There are a couple other videos out there that get into these. Lars does one, but for now we're just going to go with the generic. So I've told it it's a flange, but there is the first piece. So this is the top. Our holes are going to be in here. If you have geometry that's going to cross a bend, much like where the slots and the holes cross the little lifted tab and go down into this part of the body, you want to bend everything first and then do your geometry and your holes and your other sketching and extruding later. So we're going to do 2 more flanges. We're going to click flange, we're going to choose this edge, and we're going to pull it up. And when we pull it up, we can give it some distance. We're going to just say it's 1/4 inch. And That's solid enough in my mind. I'm not going to make a variable out of it, but we only want it to go up at about 30 degrees, just a little bit of an edge to keep things from sliding back out if it's not perfect. So at this point, the bend position's on the inside, and we're good to go. The next flange we're going to add will be back here, and this is going to be the height, or what we called the height there. This is what we called the height, isn't it? Seems big. Yes. It's the height, and there it is. So now we've bent it all up, but we haven't done any drawing yet. And the reason why is you can't draw, if we were to draw on the surface and then want to bend it, you can't. There's no concept for bending something that's already there. You have to actually create the flange on the fly. So here we go. Everything looks pretty good. Now I can tell you right away that the height in the back is way too big. I'm going to look at a ruler and I'm going to say, yeah, that's going to be maybe 1.5 inches. Alright. That looks better. So the first thing that we're going to do now is let's punch a couple of holes in the back, and these are real simple. We're going to make sure we're actually on the surface. That can bite you in the knees later. We're going to draw a circle. It's going to be somewhere in here, and then we're going to draw another one over here. I intentionally have started drawing these out of alignment and relatively different sizes, so as I start to apply dimensions and constraints, you can see them better. So we're going to dimension this circle right here, and we're going to make it 200 thousandths. I know I have a punch for that. Now this is where making them different sizes is really handy. We're going to make the two circles equal in size, and I saw the big one jump to smaller, and much better. Now we're going to dimension this one here from the side. Oh, let's come in there. Again, I'm just looking at a ruler trying to decide. Let's come in 1.25 inches. And we're going to do the same thing here. So we're going to dimension that. But we are going to go over and click the first dimension. And now they're dependent. Next thing we're going to do is we're going to dimension up from the bottom. And this is 3/4 inch is fine. It's a little high, but good enough. And then we could dimension this one the same way, making it equal, or in this case what we're going to do is we're going to make them horizontal vertical, and it will move this one. Alright, they're both white, which in mine means they are fully constrained, and we're good to go. I can no longer move these around. So, real simple, E to extrude, grab these two items, and we're going to do a to object, and we're doing this to the back side, and we're going to say okay. The reason we do to object is because if we get in and we monkey with the settings that develop this width here, we want to make sure that the holes continue to go all the way through. Alright, so we got that one done. Now on to putting in the holes and the slots in the top surface. Now, Lars Christensen did a good video when sheet metal first came out, which wasn't long ago, and he showed what I'm going to show as well. So for another way of looking at it, I'll link his video in the description below. But what we want to do is we want to have that circle and the slot and then the tapered part of the slot span between this surface and this tipped up surface. So to do that, the first thing we have to do is we have to flatten out or unfold our model. And the stationary entity is going to be this one, and we're going to unfold just that edge. We could do them both, but it really doesn't matter. So we're just going to do this one right now. And we're going to say OK. Now we're going to create another sketch. And we're going to create it on this surface here. We're going to project through into this sketch this line this one, this one, this one, just the outer perimeter. This one, and so forth, all the way around. Alright, so we've projected those through. We're going to get rid of the bodies behind it, so what we've got now is just that surface. And we're going to start by drawing some circles. We're going to draw, I think we're going to do about 5 of them. And again, you can see they're all, actually I think we're going to do 4. Now I know, because I've measured those couplings, that I want this to be 3/8 of an inch. And that'll make them hang very nicely. We're going to focus on dimensioning out this first hole right here. So we're going to dimension this out from the back, and we're going to come out, that was the shelf divided by 2. We're going to come out half the width of the shelf, and I don't like that because the fold material is being taken up. So we're going to do 0.75 here. That looks better. Alright, 3/4 of an inch there. Okay, we'll add one more dimension. Lock this to the side, and we'll set this at 1/2 inch. Looks good to me. This is where the initial drawing of things being different sizes allows you to quickly see that your dimensions and what you've meant to do has actually happened. So we're going to use this little trick where you can go over and, instead of typing in a dimension, click another dimension already there, and it's now dependent. You can see it's now a function of that other one. So we're just going to do that on all of these. The other way we could do this is to use the equal constraint. And the equal constraint, and we'll just do that real quick, take these out, I can make them bigger. The nice thing about the equal constraint is you can't hide dimensions inside a sketch. You can hide sketches and you can hide dimensions after you've left them, but not while you're drawing. So the fewer of these you have laying around, the less cluttered you are. So we're going to use the equal constraint, and we're going to say this circle is equal to this circle. And you see it jumps in size really quickly, and so it's real easy to tell that, yeah, I got what I wanted. And that one's already had an equal on it. So now that we're done with those, we're going to do some other things. We're going to make all of these things horizontal to each other. So we're going to pick horizontal parallel, and we're going to pick the center point of the circle. And again, because I drew them all out of whack on purpose, I can see them jump real easily into line, and I know I got what I wanted. So the next thing we're going to do is we're going to add some dimensions between these circles. And we're going to start with, let's try, no, that ain't going to be right. I can tell just looking. This is one of these deals where this should be, to follow my own rule, a parameter. So we're going to add a new parameter, and we're going to call it whole space, and we're going to call it 1.5. Change this here to whole space, and we're going to dimension from here. We're going to go from here to here and up, and I could either type whole space again, or I could go over here, and now we have actually 2 levels of dependency, from these 2 holes to this dimension, and from that dimension to the actual parameter setting. Now we're going to add one more dimension. It's going to be down here to the end. And Fusion's going to tell me that I'm over constraining, but I'm going to say I want to see it anyways, so that I can look at this and say, well, that's an inch, this is 1/2 inch. If I change this one to 3/4 of an inch, boom, they all move over. Now, if someone knows how to create that equal spacing between objects within a distance, leave a comment below. That'd be kind of interesting. I wanted to do that the other day too. Alright, moving on. The next thing we've got to do is draw in the slot and then the tapered opening. So we'll create some simple lines. Again, they're not in the right place. So now that we have the lines all in here, we're going to make them tangent because we want them to run right up next to the side of that circle. And This is, instead of moving your geometry, you're letting the constraints move it for you. Again, I drew them way out of place so I could see them very easily snap into where I wanted them to be. Alright, so there we go. That's all of those. We can leave these hang out here. We don't really care, or we could bring them back and we could constrain them if we wanted to. So we could say that this dot here is coincident with this line, and we could keep doing that. It's not important, so I'm not going to bother. We can still select or see these two major areas, and that's what we want to be able to extrude. So the last thing we're going to do is we're going to create another line, and we're probably going to try this a couple of different ways. We're going to do two lines like that and say we're done. Then we're going to dimension from this line to this line and pull out here, and we're going to say, you know what, that's 90 degrees. Great. Now we're going to create another line, and we're going to come off that center circle down through the bottom, and we're going to click it one more time, and we're going to click construction over here, or I could have done an X. So now what we can do is we can say that this point here is coincident to that line there. Then we can take and do one more dimension, and that's from this line to this construction line. Come on, you started to come out there the way I wanted it. Now we can do one more dimension from this line to this construction line. And why are you not playing nice? There we go. And we're going to say that this is 45 degrees. So now it's locked into that center. It's 45 degrees to the center line. The two lines are 90 degrees to each other, or we could have put a perpendicular constraint in there if we wanted. And we're good to go at this point. Now it's not fully constrained because it's not white. So the last thing we're going to do is we're going to create a dimension from that point to this line, and we're going to go over here and we're going to say that this is, we'll say this is 40,000. So let's look, yeah, that'll give us a nice little taper right here. That's fine. That's perfect. So now what I need to do is repeat that all the way across here. There we'll use perpendicular, and then here we will dimension between these two, and I'll force that to 45 and it'll swing around. I'll do a dimension from that point to this line, and I'll make it go over here, I'll make it equal to this one, and they drop right down. Alright, now they all match. Now we can do some things to pretty the sketch up if we want. Namely, what we can do is grab the trim tool, and we can go in here and trim some of these lines. Well, it gave it to me a second ago. And we could do even more. We can get rid of these half circles in here. Get rid of these, get rid of this, get rid of this. And now it's just all one big body that we can select when we go to extrude it. But that's a lot of clicking, and for a project that's this simple, I don't think we're going to bother with it. So let's go right to E to extrude, and we'll go through and select all these pieces. Okay, so yeah, it was easy. Alright, We're going to turn the bodies back on so we can see them. And we're going to do to object again for all the same reasons we did it before. We're going to extrude to back there. It's set to cut, which it assumes, and we're going to say OK. And there they are. The next thing we have to do is to refold this. And to refold, this took me a minute because it couldn't have been any bigger. It's right up here where capture location normally is. So we're going to say refold, and it's going to put back in that fold, and there we have it. Okay, with the basic model done, I'm pretty happy with this, but just for giggles, let's insert an actual fitting in here. Here, come on, MasterCard. Air hose. And boy, that was a lot of description right there. Go to quick disconnect. And again, I don't know exactly what model I've got. It's the most generic of them. This will work for demonstration purposes. We're going to get one for 1/4 inch hose. We'll pick the cheap one. And we're going to go to product details. Scroll down in product details and you can see where you can save off a drawing, and I save off the step drawing, the 3D step, and it puts it in my model. Now here's another tip I want to tell you about. When it comes to moving things, there are 5 different ways to move things around. Free move, translate, rotate, point to point, and point to position. You can do all of these all in the same process. So in the free move state, we're going to take and rotate this thing 90 degrees. Then we're going to switch to point, and this happens to be my favorite. We're going to pick the circle right here, and we're going to go over here, and it's going to give me the center of this back radius. So we're going to pick that there. And we're going to look and we're going to go, man, that looks pretty good, but you know what? I want to fudge it down a little bit just so it looks right. So now we're going to switch to translate, and we'll bring it down here. And right there, for visualization standpoint, that looks pretty good. I can spool around here. Yep, everything looks great. And we're going to just say capture position and OK. And there it is. So when you're doing a move, remember that you can use them in combination as you go along. Now that we've got the air chuck represented, I see a couple other things that I don't really like. First off, I feel like the slots are going too far to the back. And unfortunately, I didn't dimension it in the past with a parameter, so we're going to go back and do that now. And we're going to type in slot depth. And I think we made it like 0.75. It doesn't really matter. So now we've got a parameter called slot depth. We're going to go back to this sketch here and turn it on. We're going to make sure that we are back in the main part of the model. And we're going to right click and say edit sketch. And it's this dimension right here that we want to change. And we're going to make it say slot depth. Okay, 0.75. And we're going to stop the sketch, and nothing really changed except the sketch is on, so we'll turn that off. Now we can take this parameter and we can change this parameter. So let's change this. Again, we're measuring from the back forward. Let's make this 7/8 of an inch. That was right. 0.875 is 7/8 of an inch last I checked. And we hit return and it moves. Now, unfortunately, we didn't create a joint on the air chuck, so it didn't move along with it. Shame on us. But that gives us a much nicer slot. For now, we'll just hide the air chuck. The other thing I want to do, putting this away, is this is strictly for modeling. If I was to take this and want to cut this entirely on the CNC plasma cutter, this would be more important than it is today, because when we actually build this in the shop, we're just going to do this by eye. But what I want to do is I want to create a chamfer, and I want to chamfer that edge, that one, and that one. And we're going to visually move it in until it just looks about right. That's the TLAR method if you're not familiar with it. TLAR stands for that looks about right. So we're going to take that right there, say OK, and there's our part all prettied up. Okay, fine, I'll create a rule. We're going to highlight this and move it out. We're going to use translate so I don't accidentally screw something else up. We're just going to put it out here. We're going to say OK, and this time we're going to move it a lot like we were moving other geometry around. We're going to move that component around by creating a joint. It'll ask to capture the positions, and we'll do that. And we're going to create a rigid joint, much like that move was. We're going to select this component, and we're going to select that circle. And then we're going to go up here, and we're going to select the same circle. And it's going to move over there into it. Now you notice we're up high again, and I kind of wanted it down lower. We can take this arrow and drag it down a little bit. You'll notice it's changing our Z offset, which is fine. Okay, that should be just fine the way it is. We'll say OK, and now it's in there with a joint. If we go and change this dimension here to say 1 inch, it moved with it now. There we go. Now it's more like we know what we're doing. Let's go back to 7/8. We're going to call that done enough. If you've enjoyed the video and want to be alerted when the next video comes out, where I'll probably make this in the next video, click the subscribe and the little bell next to it. If you're interested in how I was navigating through 3D space, I'm using the 3D Connect Space Mouse. I love this thing. I can't say enough about it. Santa brought it to me, and I'd been hoping for one. It's very intuitive to me. I'm also setting up an independent website, sbirdranch.com. On that site, I will put a couple of exports of this drawing, and I'll also add a link to the public version of this drawing that I put out on the Fusion 360 sharing site. So thanks for stopping by the shop, everybody. We'll see you next time.